So for the second one, they give us a rule for your sequence, but they don't give us any of the terms. So what do you think we should probably do first? Find the terms, right? Because you're not going to be able to tell anything else until we get that going. So if we want to know the first term, we're going to do, that should technically be an S sub 1. So if we plug in a 1, what is 2 to the negative 1? 1/2. Okay. So then if we want to find the second term, we'll do S sub 2. So what is 2 to the negative 2? 1/4. Let's find one more just for fun. So the third term would be 2 to the negative 3, and what is that? So can you tell what our common ratio is yet? What are they multiplying by each time? 1/2, right? So if you weren't sure, you could divide, like do 1/4 divided by 1/2 or 1/8 divided by 1/4. Either way, you'll get there. So R equals 1/2 this time. And there's our first term, so that was the two things we needed. Questions there? Alright, so then looking at number 3. Again, they give you the rule, but they don't give you the term, so we at least need to find the first two. So if we want to do T sub 1, that's going to be 3 times 4 to the first power, which is what? 12. Then if we want to find the second term, that's going to be 3 times 4 to the second power. So that's like 3 times 16, which gives you what? I think somebody said it, 48. Is that alright? We could keep going, but do we really need to? We can go ahead and find our common ratio, right? So what do they have to multiply 12 by to get to 48? 4, so we just say R equals 4. And again, if you weren't sure, you could just divide, so 48 divided by 12 will get you there as well. Questions? Alright, so again, geometric sequences are going to be multiplying by some number each time. So that's that R value that we were trying to find there. The rule that we were talking about on the bell ringer for how to find your nth term, this is the one for geometric sequences, so I think this guy's important to know. There's like a random comma in there, not really sure why that's there, so sorry about that. You can erase it. There's like a random comma in front of the equal sign, so sorry, ignore that. So it's just a sub n equals a sub 1 times r to the n minus 1. So yeah, we are given a sequence right here, and we want to find the nth term. So that's like writing that rule for the nth term that we did on your bell ringers. So we're just going to plug in what we do know here. So we've got to have your first term, and we need your r, right? So what are they multiplying by each time here? Can you tell? I don't think this one's super easy to tell, right? Because it's kind of a weird fraction. So we've got a couple options. You can just divide whichever two ones you want. So you can do like 9 over 10. We could do 81 over 10 divided by 9. Either way, you'll get there. But I think if you use the first two terms, it's going to be easiest because those are probably going to be your smallest numbers. So 9 divided by 10, what do you get? 9 over 10. And that checks out if you like check it and keep going. So that's our R value. Do we know what our A sub 1 is? It was 10. That's where we started. So that's all we need to go ahead and plug into our formula. So we'll say A sub n equals your first term, which was 10, times 9 over 10, that was our R value, to the n minus 1. And that's it. Is that okay? Questions? Alrighty, so the next part wants to find the 9th term, so how are we going to do that? Plug in a 9. So we'll have A sub 9 equals 10 times 9 over 10 to the 9 minus 1. And again, you can just type that straight into your calculator. It's like a super big number, so I would recommend that you type that in. Or it's kind of messy. So do you want to do fraction or decimal? I have it as a fraction, so we'll do that first, and then you can do it as a decimal if you would like. How many zeros. 1, 2, 3, 4, 5, 6, 7. Is that okay? So that's just what you get from typing straight into your calculator. Questions there? Alrighty then. So that's that one. Are we all good on finding the ninth term or whatever term? Okay. So to find a recursive formula for your sequence, we're going to use that first equation that we highlighted up here. So basically, all you need is your common ratio for those. So we'll say a sub n equals our r value, which was 9 over 10, times a sub n minus 1. And that's it. We need to say where we started because you've got to have that part. So we'll say a sub 1 equals 10, and that should be good to go there. Questions? Alrighty. So that's how you deal with the sequences. Pretty straightforward, I think. Not too different from your arithmetic sequences, so you just gotta like memorize those formulas. So then we're going to talk about sums again. So you can still find your partial sum using that summation notation. So you can use this guy if you want to. Again, you can type that straight in your calculator just like we were doing before. Or you can use this one. I think this is the one that I use most of the time rather than that one just because it's easier, I think. So we want to find the sum S sub n for the first n terms of this geometric series. So we'll just use this formula. So we need our starting term and we need our R value, that common ratio, right? So we don't have any of those things right now, so how could we go about finding them? Yeah, just plug in values for n so you get some terms. If we find the first two, that'll be enough for what we need. So we can just do that. So we'll do S sub 1, so that's going to be 1/2 to the first power, which is what? That's just 1/2. And then if we do S sub 2, that's going to be like 1/2 squared, which is what? 1/4. So we have our first term now. We need to know our common ratio, so you could divide 1/4 divided by 1/2, or think what times 1/2 will get you to 1/4, so 1/2. So your R value is again 1/2. So then we can just plug that into this formula. So we'll say that S sub n equals, A sub 1 was 1/2 times 1 minus R to the n. So 1 minus 1/2 to the n over 1 minus R, so 1 minus 1/2. Okay? Are we all right plugging into that formula? Know where everything came from and why we put stuff where we put it? So we're going to clean that up a little bit. Can we do 1 minus 1/2? And what do we get? So we've got 1/2 times 1 minus 1/2 to the n all over 1/2. And so then what happens with those 1/2s? They cancel. So really this whole thing is just 1 minus 1/2 to the n. And that's it. Questions there? So for those, you should try to simplify them as much as you can. And yeah, that's basically it. Okay, if we're moving on to the next side, we're going to talk about infinite series now. So the sums that we've done so far, it's been like a partial sum, so just part of it. But when you have geometric series, they either converge or diverge. So converging means that it goes to the same points. Like as we continue that series, it's going to get super, super close to one number. Or if it's divergent, then that means that it's not. So it's going to like oscillate back and forth between different values. So that's what this value, or what this paragraph is talking about. So basically, if your series converges, then we can find the sum of it. If it doesn't, then we can't. So if it's convergent, that means that, or if it's going to converge, your R value is less than 1. So that's important to know. And then you find the sum by this formula right here. So again, you could do like summation notation, but this is the same thing, so I would just use the other side because it's easier after. Is that okay? So again, if your R value is less than 1, it's going to converge. So that's something that you need to know for sure, hands down. You'll have a question on it on your final exam, I'm positive. And then so the sum to find that is over here. So they'll say something like, they'll give you a series and they'll be like, does the series converge? If so, what is its sum? So that's what you've got to be able to do. So you've got to look at it, tell by the R value if it converges or not, and then you've got to have that formula memorized to find the sum from there. Is that okay? So we're going to go ahead and try that with this one. So they aren't writing the series out for you, but they're giving you like this summation notation here. So based on what it says over here, we can find our first term and our R value, right? So the first term is what? 2. So let's go ahead and I'm going to like label this. Okay, so that will help. This is a sum 1. And so then that number inside parentheses is your R value, right? And that's just based on what we've got up here. So this is our R value. So if your R is 2/3, is that less than 1? Yes, so since our R is less than 1, that means that our series is going to converge. So then, to find the sum, we are going to use this formula right here. So we'll put our first term, which was 2, over 1 minus R, which was 2/3. So what is 1 minus 2/3? 1/3. And 2 divided by 1/3 is basically like 2 times 3, which is 6. So that means that your series is going to converge at 6. Questions? Are we all right? Anything we're not sure about, don't understand? It's kind of abstract, but if you were to like take your series or your sequence and like plot out the points, if you look at it graphically, I think it makes a lot more sense. So like for this one, we'll see that all your values are going to start approaching 6, so kind of like an asymptote, if you will. It's going to get really close to that the further you go, like towards infinity. And for a series that's divergent, your graph is going to look different. So instead of it like approaching some value like this, it may go back and forth and back and forth and back and forth and back and forth. So like, have you typed in like a trig function in your graph and it gets like super wavy in the inside and then it like goes like not so tight on the ends? Do you know what I mean? That's what these would look like that are not convergent. So yeah. Any other questions right now? You all right? Okay, so we've got a couple applications down here, and honestly, I don't know that you'll use, especially this first one, but we're going to go over it anyway. So we want to show that this repeating decimal equals, should be 1 there, not 11. Again, that's a typo, sorry. So we've got the repeating decimal 0.999 that would keep going for forever. So 0.999 whatever is essentially the same thing as 9 over 10 plus 9 over 100 plus 9 over 1,000. Because that's where all those decimal places come from. So if you have 9 over 10, that's 0.9, right? If you have 9 over 100, that's 0.09. So this is essentially like 0.9 plus 0.09 plus 0.009. So if we kept going, that's just going to be like 0.9999999, right? Does that make any sense? So that's where we're getting at. So we want to write essentially like a rule like we did up here for this. So we need our first term, which we have, 9 over 10. And then we need a common ratio. So how are we going to find that? You could divide your second term by your first term. So 9 over 100 divided by 9 over 10. So I'm going to write that over here. And we end up with 1/10 there. Is that all right? So since your R value is 1/10, is that bigger than 1 or less than 1? Less than 1. So are we going to converge or diverge? converged because it's less than 1. So you would be able to find the sum if you needed to. I'm going to write that over here. It's going to converge. It's not really asking us for that, but that's okay. So since it converges, we can find the sum. So we're going to write it using this summation notation up here. So we're going to have our big sigma, and we're going to start with k equals 1. And n is infinity for us because this is like the sum of an infinite series, so we're just going to put an infinity up top. And what was our a sub 1? Where did we start? Nine over 10. What did we say that our r value was? 1 over 10. And then your exponent, I'm just pulling from up here, is k minus 1. So when we go to like evaluate that, you're using the other side up here. So we'll have our first term, which was 9 over 10, over 1 minus r, so 1 minus 1/10. So what is 1 minus 1/10? 9/10. So if you have 9/10 over 9/10, what is that? 1. Is that okay? So do we kind of see how like 0.999, 1, same thing? That's how you would like prove that. Questions there? Again, I don't think you'll have to do that. I don't think you'll be asked to do that at all. So if you're not quite sure, it's all right. So the second application that we have is talking about a pendulum. Do we know what a pendulum is? Kind of like your grandfather clock where it's got like that arm that like swings back and forth. Or a pendulum. So that's what it's talking about. So initially a pendulum swings through an arc of 18 inches. So that's like your a sub 1, right? So I'm going to go ahead and label that. On each successive swing, the length of the arc is 0.98 of the previous length. So it's getting shorter each time because like you start it and then it like slowly stops, right? So it's just hanging straight down. So it wants to know the length of the arc after the 10th swing. So we want to find, this is like a sub 10, right? So a sub n. So there's a rule for how to find that on the front of your notes. So we want to know a sub 10 equals. So if we flip back over, we are using this guy right here. So we need our first term, we need our r value, we know what n is, so we're good to go from there. So first term and r value, those are two things that we need right now. Do we know what our first term is? 18. Did they give us an r value? 0.98, that's your r. So 0.98. And our exponent was n minus 1, so we'll do 10 minus 1. Are we all right with that? We're just plugging into that formula from the front. And essentially you can just type that straight into your calculator. And what do we end up getting? I'm going to go ahead and put all the decimals. Just like, is that all right? Questions on that? Okay, cool. So the next part, it wants to know on which swing is the length of the arc first less than 12 inches. So we're going to set our formula equal to 12, and then we'll take it from there. So we know that it's going to be 12 equals 18.98, and then we don't know what n is, so our exponent is just n minus 1, because we want to know what swing got us to 12, right? So how are we going to go about solving that? Divide by 18, and then what? Logs or natural logs? Can we do natural logs? Is that okay? So if we have 12 over 18, what does that reduce to? 2/3. So we got 2/3 equals 0.98 to the n minus 1, and we'll take the natural log of each side. Why do we need to do that? What about the exponent? We want to pull it to the front, right? Because we got to like get that variable by itself, and that's the only way to get the variable out of your exponent there. So once you do natural log, we'll have, I'm trying to like not do this in so many steps, but it's not working. We'll have natural log of 2/3 equals, you could, it's either way, it doesn't matter. It should work out. You just need to do one of them to pull your exponent to the front. So then what do we do from there? Divide by natural log of 0.98. And the last thing you would need to do, add 1. And when you type that in your calculator, what do we get? .06. So if it was on the 21st swing, would we be less than 12 inches, our plane? We gotta go 22, right? Because it was at 21.06 that it was 12 exactly. So the first time it was less than 12 would be the next swing. Does that make any sense? So like if you did plug in 21 back here, plug in 21 for n. So 18 parentheses 0.98 to the 21 minus 1. Type that in. Is it bigger than 12 or less than 12? Bigger. Plug in 22. Bigger than 12 or less than 12? Less than. And it wants to know when on what swing is it first less than 12 inches. So that would have to be the 22nd. Yeah. Questions there? We all right? Okay. We're almost done. So the next part says after 15 swings, what total distance would the pendulum have swung? So does that just want to know the length on the 15th swing? What does it want to know? It wants to know your total distance traveled. So how much on the first swing, plus how much on the second swing, plus how much on the third swing. That makes sense? So what are we doing? The sum, right? So we can use this guy. We'll set it up and then we'll use that formula to like evaluate it. So you're gonna have your big sigma, k equals 1 on the bottom, and then what is our n on top? What are we going to? 15. So you're just going to have to look at that formula up there. I can't show it both at the same time. So next we need that a sub 1. And where are we starting? 18, so that's ours. Then you need your r value, which was what? 0.98. And our exponent is k minus 1. So again, to evaluate that, we're using the part that I highlighted on the other side. So it's a sub 1, your first term, 18, over 1 minus r. And our r value was 0.98. We goofed. We don't need to use this one. Yeah, because this is the one when you use for like an infinite one. That's my bad. I'm sorry. If you go back on the front, that's the one that you want to use. Or you could just type it straight in your calculator. So do y'all want to type it in here or use like the rule? The rule? Okay. So if we're using that rule, let me see. Can I like... We want that one right there. So we're going to do a sub 1 times 1 minus r to the n over 1 minus r. So 18 times, yeah, I goofed. I'm sorry. I was not paying attention. R was 0.98 to the n, which was 15, over 1 minus 0.98, because it's just 1 minus r on the bottom, correct? Yes. So that's what we need to do. And you can type that straight in your calculator, which again, you could type this in, because your calculator will do that sigma notation for you, or you can do this one, so either way should be fine. Yeah, what I wrote down earlier is what you do for an infinite series, see where it converges, and that's not what this was asking us to do. So when we do that in our calculator, when we type it all in, what do we end up getting? Do we get like 235 point something? Yeah, that's what we should have gotten. 235.288 is what I have. But all right. Okay. So then the next part, it wants to know when it stops, what total distance will the pendulum have swung. So that's our infinite series. So that's where we'll use what we had written up here the first time. So when we set it up, the only thing that's going to be different, k equals 1, we're going to have an infinity on top. Everything inside is still the same. So then we will do that a sub 1 over 1 minus r. And so this time, what do we get? 900. Questions? How do we know that we were able to use that formula here? What tells us that it converges to some number? What in your formula? R is less than 1. So you gotta be checking out that R value, make sure that R is less than 1. If that R is not less than 1, then it's not going to converge. So like if we go back to the front of our notes, would this one converge or diverge? Diverge, right? Because your R value is bigger than 1. Would this one converge or diverge? Converge, because R is less than 1. And this one? It would diverge, right? Because R is bigger than 1. Are we okay on that? So, I'm not sure why, but that's like something that they really stress on this topic is like converging and diverging. So, just make sure that you got that. You all right? Huh?
What are you doing about it?
It just means that you can't find the sum. So, you basically just say it diverges and you're done. Yeah.